Hi Year 13s. In this video we're looking at kinematics, which is basically how we deal with velocity and distance and acceleration using calculus. Before I get underway, I'll just point out that my son is right here, so he might make a few noises while we're trying to work through our things here, so just be aware of that. But anyway, we'll get on with this example and hopefully he doesn't make too much noise. Okay, so here I've just got a summary of basically how we get from distance to velocity to acceleration, or going the other way from acceleration to velocity to distance. So if we're going from acceleration to velocity, we integrate. From velocity to distance, we integrate. But going the other way, we differentiate. And so that's really what you guys are interested in at this stage. Now, as far as integration goes, we may have to talk about that a little bit in class because we haven't really covered that yet. But let's just try and deal with differentiation at this stage. So we've got an object following this pattern or this function here. And the first question is asking us to write a formula for the distance. So because we're going from velocity to distance, we would have to integrate that. Now I know we haven't covered integration, but this is quite a straightforward piece of integration because we're just doing the opposite of differentiation. So I write out the function 3t squared minus 6t minus 24, and if you don't follow this method, don't worry too much because we'll look at this more when we get to integration. Okay, so let's integrate it to find a function for distance. And what we're going to do is raise the power by 1, so I'm going to raise my power up to 3, and divide by the new power. So because I'm dividing 3 by 3, the powers, they cancel out. I'm just left with t cubed. Then we've got t squared, and 6 divided by 2 is 3, and then we've got minus 24t. And then I'll talk about this more when you get to integration, but we have to include a constant of integration. So that's just because we could have a something that ends up being like this 24 here. Okay, in our next question, work out the initial velocity and acceleration. So the initial velocity will be when t equals 0. So all I'm looking for is v of 0. So that will be 3 times 0 squared minus 6 times 0 minus 24. And so that gives us negative 24, and that's in meters per second. So that's our initial velocity. So for initial acceleration, we need to work out a function for acceleration first, and that's going to be the derivative of our velocity. So that's going to be 6t minus 6. And we're going to put 0 into that, and so our acceleration when t equals 0 is going to be 6 times 0 minus 6, which is negative 6 meters per second per second. Okay, question C is asking when is the object at rest. Well, the object is at rest when velocity equals 0, so that's when v of t is equal to 0. So v of t is 3t squared minus 6t minus 24, so this is just a quadratic. So we'll start by dividing through by both sides by 3. So we'll have 0 equals t squared minus 2t minus 8. And now we'll factorise this. So we've got 0 equals, and in brackets we've got t squared, t and t, and we're going to have minus, let's see here, minus 4 and positive 2. And so our two possibilities are t equals 4 or t equals negative 2. Now since only one of these makes sense in the context of the question, which is 4, we're going to ignore this one here because we can't go backwards in time to find when it was at rest. Okay, question D. Actually I haven't answered the next. Oh no, I have answered it. Okay, question D. When is the object travelling at its minimum speed? So minimum will be when the gradient is equal to 0. So I need to take my velocity function and differentiate it, which is my acceleration function. So that's 6t minus 6. and I need to set that to 0. So 0 equals 6t minus 6, and so 6t will equal 6, and so t will be at 1. So at t equals 1, our velocity is 0. Okay, and our final question, when did the object return to the origin? And so that will be when the distance is 0, and so actually we're not going to answer that question either, because that involves our integration, and we won't worry about that just now. Okay, so I'll get you to have a look at these examples here. If there are any that require integration, have a go if you want, but if you're not quite sure what to do, just skip those at this stage, and we'll deal with that when we get to integration. Other than that, that is the video.